So a very, very quick lesson on partial pressures. This is something that's just very minor, but I wanted to make sure I covered it. Partial pressure is basically when you have different gases in the atmosphere, which is more realistic. The Dalton's law of partial pressures is that all of these gases combined, all of their pressures combined, will give you the total pressure. So, for example, if we have the pressure of oxygen in the atmosphere, the pressure of nitrogen, the pressure of carbon dioxide, pressure of argon, when you combine all of those together, that gives you the total pressure, and it's just as simple as adding them up. So, just a couple of definitions. Partial pressure, this is the pressure each gas would exert if it were the only gas in the container. And then you have the law of partial pressures, is that the total pressure is the sum of all those partial pressures of gases in the mixture. The other thing that I want to draw your attention to is that it's the pressure of the gases is affected by the number of particles. It has nothing to do with the nature of the particles. It's just solely based on the number of them. So you can have the same atmospheric pressure, 8.04, if you have 1.7 moles of helium, or if you have 1.75 moles that's made up of hydrogen and helium and neon, or 1.7 moles of nitrogen, oxygen, and argon. So it doesn't matter the nature of the particles at all. It's affected by the number of particles. So basically from that, the volume of the individual particles is not important, and the forces among the particles must not be important either. So if we just look at this as a very quick example, you have a flask with a pressure of 152 millimeters of mercury, and then you have another flask over here with a gas in it. This one's of helium and this one's of hydrogen, 608 millimeters of mercury. So these are the two pressures of each one individually. And then if you combine them into one, you have 152 and the 608, and that gives you a total of 760 after they're mixed. So basically, the total pressure of a mixture of ideal gases is the sum of the pressures that each gas would exert if they were alone. And we're not going to be doing this lab where we're collecting gas over water, but basically the barometric pressure is the pressure inside, which is equal to the pressure of the gas plus the pressure of the water vapor, and so you can use those calculations. Anyway, we won't be dealing with that, but I just wanted to make sure that you had an idea of what Dalton's law of partial pressures was about.